All right, Chapter 6, we're going to see some things that are probably less familiar. A lot of you have seen mean and median before. You've seen histograms and bar graphs. So we're going to venture into maybe some new territory. So what we have that I'm going to show you today is what's called a z-score. Z. Why the letter Z, Miss Curtis? I don't know. So z-score. We calculate a z-score this way. We take a piece of data, so I just call that x. It's just some number, and we subtract x bar. That's one way to symbolize the mean. And we're going to divide by s, which is our standard deviation. You will see the z-score formula written this way in words on the AP test. So just maybe get familiar with seeing it both ways. This with symbols is in your textbook. And this with words will be on the AP exam. Statistics, so that's like a single value, a number minus parameter, divided by the standard deviation. Don't stress too much about this. I just want you to have seen it, okay? So let's focus today just on our numerical textbook version. So we're going to just practice finding a couple z-scores. And we're going to do that where we have a mean or an average test score that's 68, and the standard deviation is 3. We're going to find the z-score for each of the following. So let's pretend that some student scores a 65. Well, what's the z-score? I'm going to use my formula just above. Z equals x. Well, this would be my actual piece of data. The student scored 65. Minus x bar, that tells us I need to subtract the mean, 68. Divided by, well, s, that's my standard deviation. It was given to me as 3 in the story problem. Now, please be very careful when you type this into your calculator. If you type it in just the way it looks, you're going to run into some problems because of the order of operations. So subtract first, divide second, or possibility, use parentheses. And you should get an answer of -1. Now, negative. Well, notice this student, 65, the mean was 68. This student scored below average. We're representing below with a negative. All right, let's check out another one. This second student scored a 72. So x, that's the student score, z equals x, minus x bar, that's the mean. The mean is still 68. Divided by the standard deviation, that's 3. So I can plug this in my calculator, and I'm just going to round it off. I got 1.33. Notice this one is positive. Positive because this student scored above average. 72 is more than 68, above average. All right, let's do just one more here. One more z-score. My student scored 74. That's my x. I'm going to subtract the mean of 68. Divide by the standard deviation of 3. Again, put this in carefully, subtract, and then divide, or perhaps use parentheses. And I got an answer of 2, 2.0. Again, notice it's a positive number. That's because this student scored above average. All right, so yay, Miss Curtis, I can plug it in a formula. What's it good for? Well, we'll get to that momentarily. I want to point out one more really important thing. Z-scores are changing the scale into standard deviations. Notice that my student who scored 65, if I added 1 standard deviation, which is 3, I'm going to get 68. So this student is 1 standard deviation away from the average. 1. In which direction? Well, below average. That's that negative sign. Let's talk about 74. Well, if I have 68 and I add a standard deviation, that takes me to 71. If I add another standard deviation of 3, that takes me to 74. So this student is 2 standard deviations above average. So I'm just finding a way to measure how many standard deviations above or below average. That's what a z-score is good for. All right, let's check out an example of something you might be asked to do with a z-score. Story says, although most of us buy milk by the quart or the gallon, farmers measure daily production in pounds. I had no idea. Guernsey cows average 39 pounds of milk a day with a standard deviation of 8 pounds. Jersey cows average 43 pounds of milk a day with a standard deviation of 5 pounds. Suppose a Guernsey cow and a Jersey cow both give 45 pounds of milk. Which cow did better? Well, you might be thinking, well, they both gave 45 pounds of milk. That one did not do better than the other. But as a matter of fact, they did, because the Jersey cow should be getting around 43 pounds, so he's only done 2 pounds better. The Guernsey cow usually only gets 39 pounds, so he's done 6 pounds better. So, wow, maybe we should be leaning towards the Guernsey. But what we also need to consider is that the Guernsey has a bigger standard deviation, more variety in what they can produce. So to help us put these on the same scale, we're going to calculate z-scores. So z-scores help us get things on the same scale. So we can compare things that are usually not comparable. All right, so for my Guernsey cow, I'm going to calculate my z-score. Well, it's how they actually did my piece of data. So my Guernsey cow did 45 pounds. I'm going to subtract x bar, that's my mean. Guernsey cows average 39 pounds, divided by a standard deviation of 8. And when I plug that all in my calculator, I get 0.75. So this Guernsey cow did above average. It's a positive number. Well, how much above average? Well, not quite a whole standard deviation above average. 3/4 of a standard deviation above average. All right, let's check out our Jersey cow. See how she did. Jersey cow. For my z-score, again, I'm going to take my x, that's the number I'm interested in, 45 pounds of milk. I'm going to subtract the mean, x bar, that's 43. I'm going to divide by the standard deviation, that's 5. And for this one, when I type it in my calculator, I get 0.4. So notice my Jersey cow is also above average. Well, how much above average? Not quite half a standard deviation above average. So who did better? Well, certainly the one who did more above average would be the more successful or more surprising. So it looks like our Guernsey cow actually did better because she did more above average work. All right, so that's basics of z-scores. Calculate, get things on the same scale to help us compare.